In this video, I'm going to show you how to derive the Pythagorean identity with similar triangles. To derive the identity, we will be using the formula the sine squared of theta plus the cosine squared of theta equals 1. As an example, let's use the triangle below. For this example, theta equals 64. On this triangle, my short leg equals the cosine of 64, and my long leg equals the sine of 64, and my hypotenuse equals 1. To prove that my hypotenuse equals 1, I'm going to split the triangle down the 90 degrees mark. To prove that the split triangles are similar, I'm going to compare each one. For this triangle, I'm comparing the long leg and the hypotenuse. My long leg in this triangle equals the sine of 64, and the hypotenuse is x. So I need to get x by itself. After doing this, so I need to multiply each side by the sine of 64, and then I get the sine of 64 equals x. On this triangle, I'm comparing the short leg and the hypotenuse. So I've divided on the main triangle, I've divided the cosine of 64 by 1. On the smaller triangle, y is divided by the cosine of 64. To get y by itself, I need to multiply the cosine of 64 on each side. So once I do that, I have the cosine of 64 squared equals y. Now I need to know if these two together equal 1, so I'm going to plug these back into the original equation, which reads as the sine of 64 squared plus the cosine of 64 squared equals 1. Now to test that, I'm going to put the sine of 64 squared plus the cosine of 64 squared, don't want to square problem, squared equals 1, and I've just derived the Pythagorean identity using similar triangles.